Welcome back. Let's talk about data science. For starters, you need to understand we have this expansive chain of mathematical fields that are fundamentally important to one another. The same way probability sets the foundation for statistics, statistics constructs the pillars on which data science is built. To me, the more general the issues, the more we rely on the simpler concepts from probability, and the more concrete our interests are, the more we need to delve into data science. All right. As we mentioned, toward the end of the last lecture, regressions are essentially supervised machine learning. Therefore, any successful data analyst, data scientist, or data engineer needs to have a very good understanding of statistics and, of course, probability. In data analysis, we usually try to analyze past data and use some insight we find to make reasonable predictions about the future. Furthermore, in mathematical modeling, we often tend to run artificial simulations to see how well our predictions match up to various possible future outcomes. One such approach is called a Monte Carlo simulation. Before moving forward, let's discuss what a Monte Carlo simulation consists of. We generate artificial data with which to test the predictive power of our mathematical models. Usually the data is not completely arbitrary, but rather follows certain restrictions we provide. For instance, if the probability of a specific outcome is 0.4, then 40% of the artificially created data must match this outcome. This is convenient because we can tweak these restrictions to see how much our model is dependent on the data we have fed it initially. This is crucial as many models look well when we train them on our initial data, but perform poorly when deployed in the real world. Okay, furthermore, data science relies on expected values much more than you would believe. Most machine learning is an extremely fast-paced trial and error process where the computer adjusts its expectations as it goes through the data. Essentially, the more predictions it makes, the more precise they become. Right. The future is uncertain, so data scientists often try to predict what will happen based on information they have about the present and the past. Even though machine and deep learning processes tend to yield very high predictive powers, they are still not 100% certain. Each prediction has a probability of being incorrect. That is because there are unpredictable events that can occur in real life. Earthquakes, volcanic eruptions, or sudden scientific breakthroughs can completely change the anticipated course of events. Thus, even data scientists assign probabilities to their predictions, however accurate they may be. In essence, data science is an expansion of probability, statistics, and programming that implements computational technology to solve more advanced questions. Even when using it to predict future outcomes, there is a degree of uncertainty of what the future holds. That is why it is fundamental for anybody striving to be a data scientist to understand the basics of probability. Marvelous work, everyone. We have reached the end of this course. I hope you enjoyed the journey filled with certainty and uncertainty, combinatorics, sets, and distributions. After completing this course, you will start noticing probability in your everyday life more. Probably, you will be getting into a probabilistic mindset when facing problems and approach issues from a newly found perspective. I'm certain you're ready to transition into more complicated topics of both applied and pure sciences. Statistics, data science, and financial modeling are only some of the numerous fields you can explore after mastering the foundations of probability. But before you do any of that, take a moment to appreciate how much you have learned. You've now been introduced to the world of uncertain events. You know how predictions and forecasts are made based on past data. You know that getting heads 5 or 10 times in a row does not make it any less likely to get heads on the next flip as well. That one will blow your friends' minds. You also know about conditional probabilities and how to correctly interpret the complicated summary tables in the appendixes of papers. Most importantly, appreciate all the hard work and dedication you put into learning the fundamentals of probability theory. Good luck, and of course,